Okay, so as many of you are curious, what is HDFS and yarn? So we'll take a brief introduction about what is HDFS, okay, and then we'll we'll continue in the tomorrow's session. So let me tell you what we are going to learn in the next few minutes. We'll try to understand what do we mean by HDFS, which is distributed file system, and how exactly it works, right? And then we'll see some of the examples like how to use HDFS and how to use a file browser using the Hue and all of this. We'll try to run some of the HDFS commands, not today, but in the next class. And then we'll in the same session we'll have some detail about how does the yarn work. We'll go through the different components of the yarn, and then we'll see how to access the yarn UI and how to monitor the jobs running in a cluster and all of these things, right? So that's the agenda of this. Oh, that's a very good question. What is the full form of yarn? Does anybody know what is the full form of yarn? What is the full form of yarn?
Yet another resource negotiator.
Yet another resource negotiator is a full form of yarn. So it's kind of see, I give you a little background. So Hadoop so far has gone through two major releases. Okay, Hadoop 1 and Hadoop 2. So Hadoop 1 was a traditional MapReduce. They call it something. There was some concepts of the traditional way of doing this MapReduce, but there were some limitations of it. Okay, and to overcome those limitations, they come up with the concept of yarn. Yeah, so there was some issue with the resource management and the application monitoring. These were some of the concepts where there were some issues related with the first version of the MapReduce, right? So they introduced yet another resource negotiator. The name is like yarn, but the idea was to introduce some another component to overcome the issues of the traditional MapReduce, which is Hadoop version 1. So the one that we are going to learn and the one which is running in the market and everybody uses is Hadoop version 2, which is the Yarn framework. Okay, so we'll go in a detail about it. So let's quickly talk about HDFS. Now, HDFS, as we all know, like it's a distributed, right? So instead of storing data in one server, we are distributing it across multiple different servers. And why we are doing it? Because we want to access the storage of all of them, right? And we want to distribute our data among multiple workers, multiple nodes, so we can run them in parallel. We can process them in parallel. That's the idea. Okay. Now, if you really see why we cannot use a traditional system, if you really think, what is the problem of using a high-end server? Right? In your project also, if you really see, like if uh, they have some resource constraint and all this, okay, we'll go with a higher server. If I today I have a 1 TB of capacity, I will go with a higher uh, server which will have 5 TB or 2 TB, right? So scaling up definitely you can do, but certain to some certain extent, but like to some certain extent, right? And it adds up a lot of cost. So one of the major challenges is the cost. If you go with a very high-end server, you end up paying a lot of dollars, which is not worth. Okay. The second thing is, even though you go with a very high-end computer, but still you will not be able to match the speed what you can get by distributing the workload. Just think about parallelly processing by 100 nodes compared to one server processing the data. So how much, no matter how how higher you go, you cannot match the speed of parallel processing. Okay. So, and the third thing is about the reliability. So, like fetching the data is difficult if you have, uh, if you are going with a very high-end server, and then let's say there is reliability is the issue. Let's say you have multiple data centers and across different geography, right? So sometimes there is a challenge. So if that one particular server is down, right, which means your entire application is down unless you have a backup of that. And if you're creating a backup of that server, which means again you are spending the same amount of dollars. Actually, it's not a reliable, and that's why nobody is nowadays going with the high-end component. They are going with the distributed components. So that's what the need of is. We have to bring down the cost. There is a need to go with a distributed file system to have a reliability, to have a speed in the processing, right? Faster processing and all. There's a need to go with the HDFS. Okay. So what does HDFS provide? It provides me a low cost component which is reliable and also very fast. All right. So if I do a brief comparison of HDFS with a regular file system, so a regular file system has a very small block size. Can anyone tell me what is a block size? What do you mean by a block size?
A unit which stores the underlying data is the lowest unit to store the data.
And what is the block size for big data? It's difficult to find them. Right? It's simple. If you have everything in one location at one place, you are reading it. You are consuming lesser time than to find out where all the pieces are placed together. And that time which you spend to locate the block is known as a seek time. Over here, if you see seek time, right? So the time, let's say there is a file, it has 100 blocks. So if I have to read this file completely, I have to find out where those 100 blocks are present. Okay, and then I have to read one block after the another. Right. So if I have the time which is spent to locate all of those blocks is known as seek time. So if I have a smaller block size, I will have so many blocks, and the time spent to locate all of the blocks will be more. Right. So in order to reduce the amount of time spent in locating the blocks, or in technical term, in order to reduce the seek time, they come up with the idea of a larger block size. Right. And the second purpose was like because it is meant for a huge amount of the data for a big data, so it makes sense to have a larger block size so you can read a larger chunk at a time, right? Because if I have to process 1 TB and I am reading 1 KB in one time, which means that's not sustainable, right? So that's why they come up with the idea of a larger block size. Okay. So access to the large data. If I have a smaller in a regular file system, if you store some very large file, so it will suffer from the disk I/O problem because you have to locate the blocks, right? You read one block and then you read another block and read another block. So there'll be a lot of disk I/O. So to reduce all of these things, they come up with the idea of a larger block size. Okay, is it clear to everyone? All right. Now,
But still underlying file system is regular file system only. Huh?
yeah, underlying
HD
file system. Right. Underlying file system is the operating system for OS file system. That is correct. But HDFS is a layer on top of that, right? So while you are reading a chunk, you are reading the entire chunk, no matter what. So it's a logical representation of your file system. HDFS is a logical representation of your file system on top of your OS level file system. Okay. So while reading this entire block, if one block is 128 MB, while processing you will consume 128 MB. You will not read this smaller kilobytes of the data. You read the entire 128 MB in one go, and you will process that in one go itself.
Yeah, but when I'm reading from HDFS, but the point is like HDFS in turn has to read from the actual file system, right?
Right. So, yeah, absolutely. HDFS has intent to read, but you are not using the system OS level calls to read it, right? You are using the HDFS APIs to read it. So while you are using HDFS APIs and the HDFS program, it will read this much at a time.
Yeah, and maybe like HDFS has better algorithm or mechanism to read from normal file system.
Yeah, so see, the intent is I want to read a larger chunk of data to avoid the disk. I want to read a larger chunk of the data. If I'm using HDFS, I will read 128 in one time. If I have to, if the same file I read from a Linux file system or from an Oracle or from any such type of thing, traditional file system, then I have to use OS level programs, and then those things will be consuming this smaller block size, right? But assume HDFS is an abstraction on top of your OS, right? So instead of calling these OS level APIs, you are calling HDFS APIs, which is reading a larger block of the data.
But again, I mean, I'm not directly calling the OS level APIs, but HDFS is calling, right?
No, HDFS is not calling that. So there's a difference. See, file storage in your okay. See, your OS is having underlying whatever kilobytes or something like that, right? Where this, in your operating system, if you are reading some IO operation, you are making some OS level call. Let's say if it is Linux, you are making some Linux operating system level call to read this particular file. Then it will consider this bytes or this many bytes as that, right? But that's not the case with the HDFS. It's a Java program. So it's a Java program which is saying I want to read this much of the data in one go, right? And that much of the data will be processed in one go. So you are separating a layer from your normal operating system I/O with a Java. So how does Java works? Usually you create a virtual environment, and then whatever abstraction you do, it all runs within that program itself, right? As part of the JVM. Okay, so there is a demarcation line where you are not saying that my block size, I'm not going to read these many blocks. I'm going to read entire 128 blocks. Underlying, if let's say you are saying, okay, with 120 MB of the data might have to find out all these small things and might have to give it, yeah, that is true. Right, that is true that it has to underline go and look at all of these blocks, but while I'm processing the data, I'm processing the entire 128 in one go. So a layer which is between my program and the OS is ensuring that I'm getting all of those in one go, so that if I'm processing one block and going to another block, I don't have to switch to so many blocks, but one block I can process entire 128 MB.
Dhiraj, I have a quick question here.